Good afternoon, ladies and gentlemen. It is a pleasure that you could join us today for the webinar on how new modeling technologies can boost design productivity in small and mid-sized companies. The webinar is presented by Construction World in association with Siemens. Today's machinery design is about more than just mechanical design. Upfront digital validation will allow you to deliver machines to customers without any issues. In addition, with increased electrical, automation, and software content, today's machines will be able to solve all the issues concurrently across multiple platforms. Let's learn more about generative design and how it works, discover new design methods, and definitely see some examples on how it's accomplished. Before inviting our speaker today, I would like to introduce you to our magazine Industrial Product Finder and talk about 3i Expo that we plan to organize on 20th and 21st of May. Industrial Product Finder magazine, launched in 1972, celebrates 50 years this year. It is one of the oldest and most trusted brands in industrial publication space and a go-to magazine for several decision makers. IPFonline.com, launched recently, has a wide digital presence and brings to you all the updates at a click of the button. One of our most recent offerings is iNow, IPF on WhatsApp, and I am requesting everyone to just give a missed call on this number and stay updated on the latest industry news. You can just grab a screenshot and use this number to give you a missed call. Apart from the magazine, we do organize expos, conferences, seminars, and awards. Some of the recent successful events, we did around 30 successful online events in 21. And since October last year, we also started doing physical events in Mumbai and Delhi. These are few snapshots of the same. Digitalization. Digitalization is changing how products are designed, fabricated, used, and serviced, just as it's transforming the operations, process, energy footprint of factories and supply chain. With 3i Expo, we envisage to bring all the stakeholders contributing to this Industry 4.0 and digital transformation on the same platform. Our motto behind this event is to create a platform where we learn, network with industry influencers, and we strategize to optimize, modernize, and innovate. MIDC is our presenting partner, and we are doing our associate partner IFM, Knowledge Partner Industry, Automation Industry Association, and we also have supporting partners like TPMAI, MAIT, and several other supporting associations, which will definitely bring the right kind of stakeholders to this platform when we plan the panel discussions, the keynotes, and the audience as well. Mr. Sanjay Bhatia will be the guest of honor. A few of our past chief guests include Mr. Subhash Desai, Mr. Hafiz Contractor, Ajit Chan, Arun Goyal. Coming to the conference agenda, over the 2 days, we plan to discuss the issues that are pertaining, the challenges, and provide implementable solutions in the future of manufacturing. We will definitely talk about capital cost versus productivity, and this session will talk about financial exploration and ROI of the technology that we plan to implement. We will have case studies that will validate the use of Industry 4.0. They'll talk about advantages, challenges, and solutions, how they are implemented in today's smart factories. A manufacturing innovation hub will give a flavor of all the modern technologies that are available like 3D printing, 5G business cases, IoT, cloud, and much more. On day two, we talk on the policy intervention and how we can make India the next manufacturing hub. This panel discussion and keynote will be followed by the 6th IPF Industrial Excellence Awards. We are doing a series of webinars as well. The next webinar is planned in April, and I request everyone to stay to connect with us to get more updates on the same. You can connect with my colleague, KS Fareed, if you need any other details of the 3i Expo. Please save the date on your calendar, which is 20 and 21st of May at Nehru Center in Mumbai. With this, let me invite our speaker for the day, Mr. Avinash Gangaiya, Portfolio Development, Product Engineering Solutions, Siemens Digital Industries Software. Avinash is an experienced technical consultant with over 10 years of experience and has helped customers deploy and use digitalization solutions in areas of product development and manufacturing in automotive, defense, heavy equipment, industry machinery segment. With his experience of using digitalization technologies to streamline processes, he possesses an in-depth insight on these technologies and their applications for supporting variety of organizational goals. With this, I hand over to Avinash to take us through his presentation. Over
Thank
to
you. Thank you, Rishali. So let me get my screen shared. Yeah, I hope my screen is visible to everyone. Rishali, if you're able to confirm, that would be. Okay, so first of all, good afternoon, everyone, for joining in and for your time. So, thank you, Rishali, for a brief introduction. Thank you for that. And with that, I'm happy to talk about this topic and then discuss with you on what's happening in the industrial machinery space and what are the new technologies that are there and that are being quite fast adopted across the industry, and also how an SMB or a mid-sized market company can go ahead and then adopt these technologies in order to gain a competitive advantage. So with that, over the next 45 to 60 minutes, I'll go through these technologies. I'll talk about the key trends that are happening. I'll talk about what are the technologies that we can leverage, and I'll talk about how we can segment the approach in terms of where anybody can get started, be it in one of the areas or pillars of these technologies, and then get started. We can choose what would be the vital regions or technologies that is something that would add value to your organization depending on what phase of the product development that we are looking at improvising. And then very importantly, also the flexibility with which you can adopt these technologies and how Siemens is helping organizations with respect to the scale. So with that, let me get started. And the whole theme for the next 45 to 60 minutes is all about trying to understand how and what is driving the industrial machinery space. It's all about automation, it's all about machines being connected, it's all about ensuring any machine that is there, trying to make it and trying to ensure that they're as adaptable as possible, right? And this is what is more or less defining the overall future for the next couple of years, and trying to understand how you're able to gain a lot of information of these machines with all the data that we are capturing. How do we go ahead and then improve the next generation of these machines and all these things, right? So but if you have to summarize what's happening basically as a trend, right? There are a couple of trends that we can look at across the globe in the industry. And the very first thing that we personally anybody can see also is a lot of customization that's happening, and these customization leads to privatization, leads to a lot of personalization happening on the machine side, right? So it can also be, a lot of them can be from consumer driven based on what they're looking at. And we are also looking at machines getting more and more smarter. When we say smart, we are talking about, how are we able to gather information from them, gather information in terms of, how long has it run, is it going to go down, or is the machine good enough or not, do I have to make any changes to it, is it over designed or is it under designed, right? All these things are something that we are looking at. And a lot of things are also, like I mentioned in the second slide, it's all about automation, right? So how do we take care of that? And because of all these things coming in, you also see a global competition coming in, right? With global competition, they also come with a plethora of offerings also in terms of different business models, maybe, machine as a service, right? I've been talking to a lot of machine manufacturers where they're also looking at not just selling the machine, they're also providing the machine as a service with more or less 99.9% uptime, trying to ensure provide guarantee in terms of trying to ensure that this is going to run n number of cycles, this is going to be made available without any kind of downtime and all those things, right? Try and understand how do you reduce, how do you differentiate yourself across the competition, right? So but these are the trends that we are looking at. But because of this, right, so when any organization is looking at this, and then you say, okay, this is a trend that I understand. So if even if you have to look at or think of getting started with some kind of an adoption, we'll start seeing a lot of challenges coming in. And what are these challenges, right? These challenges can be a lot of things. It can be in terms of ensuring how personalized these assets that we're building can be. And with when we say these are getting more and more smarter, you also need to look at having an integrated platform, because we are not looking at just mechanical products alone. It's also about when we say smarter, it includes a lot of software and electronics into it. So how do we have an integrated platform in place, right? And with all these getting added, we should also need to ensure that if they're connected, only then we are able to gather as much information of how it is being used in the market. And then how we are able to gather that information, make use of it, and then be able to build a better product in the next variant, right? So how do we go ahead and then do that? And while all these things are happening, we should also ensure that they are as secure as possible with all the data coming in, and yet at the same time they need to be sustainable and cost effective, right? If we're not cost effective, and then if we're able to give the best product, it's going to be a little challenging. And then we need to look at how it can help us on the margins as well, right? So what we are saying is that while we are able to see the trends, and because of those trends, we also see some challenges coming in, right? And the point is to look at these challenges and try and see, hey, look at it in a different perspective, in a perspective of looking at these challenges and then trying to use them to our competitive advantage, right? So how do we do that, right? So we can look at achieving a comprehensive digital twin. When we mean by a comprehensive digital twin is that trying to get a digital twin of right from your conceptualization of the asset till the time it is being manufactured, deployed, and then being used. Build a comprehensive closed loop cycle and then be able to gather more information of it, and then the cycle continues, right? So that's where I'll talk about this in depth. And I'll also talk about how a personalized ecosystem or a platform that is very important, but yet at the same time need to be modern as well, to help you adopt all these new age technologies. And yet at the same time, while all these new age technologies are there, it should also provide any customer, any manufacturer, the flexibility to be in a position to adopt uh, you know uh, solutions and then technologies from XYZ different platforms, right? So that's where an open ecosystem is equally vital. While flexibility is important, but an open ecosystem is equally vital to ensure uh, giving any organization, any manufacturer, the flexibility to be able to adopt and then integrate seamlessly across any of the best technologies that are there, right? So that's where Siemens's Accelerator portfolio comes into play. And when we say Accelerator portfolio, it's basically a suite of software offerings from Siemens. And let me turn on the pointer. And it can help you from right from the time you conceptualize, like you said, from your product design with mechanical offering, and also with all the data that you create, right? You should also be able to manage the data, right, in terms of collaboration, and with like I said, a lot of them being more and more smart, which also means a lot of software getting involved. So how do you manage all the applications? It can also be in terms of your IoT and analytics. When we say Internet of Things and analytics, it can be two things. It can be two ways of looking at it. One, in terms of smart connected machines, which means a smart connected product. So thereby you have all of your products captured, with a lot of sensors in place, capture all the vital metrics that we need, and then be able to capture it either in an app, trying to understand the downtime, try to understand the usage, make use of that, and then try to build the next generation product in a better way, right? Or it can also be a smart connected manufacturing, where we are looking at you connect all the machines on your shop floor, try and understand the improve try and understand how you can improve the OEE of the shop floor, and then ensure there are no downtimes coming in, and the like. So there are these approaches that you can take, and of course on manufacturing and operations you'll be able to look at technologies that will help you to optimize and then improve the productivity. But whatever product that we build, we should also have to ensure the integrity or the structural integrity of the component or the product is not compromised, right? We should have the confidence on the structural integrity of the component, right? That's where a digital twin and a technology that will help you to achieve that via digital simulation is very, very important. And I said, today's components are not mechanical anymore, they involve a lot of electronics also in place, right? So that's where you need to have a platform that will help you to have a seamless integration between your electromechanical teams in place. And that's where in today's session we're talking about how the design tools that will help you to go ahead and then adopt to help you build the new age industrial machinery to with the help of new age suite of tools. I'll talk about all of them in depth in the next couple of slides. But so when you say any digital data, right? When we say any digital twin, it is not just one CAD model alone. It is also about, it is also about a digital process in terms of not just design. It is in terms of design and development. For production development, you need to also ensure there are no challenges in terms of manufacturing. You need to also ensure you're able to quickly gather the data, gather an understanding of how it is being used, capture all the metrics, and then be able to have a closed loop life cycle to go ahead and then be able to build the next generation of the product in a much better way, right? So that is how it is. So if I have to probably look at an ideal scenario, right? So uh, the one that you're seeing on the slide is the world's fastest packaging machine. And then if you look at this machine, there are a lot of technologies that you can look at and then try and understand. And then any organization, any manufacturer says, okay, this looks good, and probably this is something that the path that we would like to try and understand how what all technologies that we can look at to improve our current generation of machines that are there, right? And this is built using Siemens's software portfolio, using NX, right? So how do we do that, right? So what I've done is I have I've in the next couple of slides I'll talk about how we can look at these new age technologies, but I've also placed all these new age technologies in about 6 pillars. And these pillars is where we can look at each of those pillars separately, and then we can look at where and how we can look at improvising our existing product development. And then we can also look at how each of these pillars will add value to your overall product development. And it can also come from as basic as your product modeling environment itself, right? So when our design engineers are working on building the product of the future for us, right, at the same time they should have all the necessary tools that will help them to be more and more productive. I'll talk about all of these in detail in next couple of slides, but I just wanted to highlight our focus over the next couple of slides will be on these 6 pillars that I'm talking about, in terms of as basic as your product modeling environment itself. But at the same time, because I'm talking about a lot of integrated design and manufacturing happening, we're talking about electromechanical design with a cross discipline information flowing. I'll be talking about the integrated simulation and ensuring manufacturing. With all these data that is coming in, how are we going to go ahead and then collaborate across the stakeholders, right, by sharing the data and then ensuring we're able to capture and then work with other stakeholders, right? I'll talk about generative engineering in depth. We spoke about it when Rishali was briefly highlighting about what we'll be covering today. And then I'll also talk about, one technology that is gaining a faster pace of adoption is additive manufacturing. I'll talk about that as well, right? So let's focus on most productive modeling environment itself. So when we say modeling environment, you would have seen a lot of engineers work on working on the concept, working on building them, and then building the digital twin of it, right? So how do we go ahead and then do that, right? And NX, Siemens invest over the last year, we've invested close to $100 million in the NX development itself, right? And that talks about that itself is a testimony towards the interest and the focus that we have on these product modeling technologies as well. So if you look at the most productive modeling environment, we're talking about how easily even from a user interface standpoint, the user is able to quickly build the sketching and the concept in terms of the way he'd like to focus, and then be able to achieve the design that he intends to have, and yet at the same time get rid of any of those iterative processes that will go into loop, and then he's able to arrive at the concept and then build it quickly, right? So you look at a very simple user interface, anybody can get started quickly and then start working on the concepts. So with that, if you look at any machines, right? So we are also looking at, I'm just trying to look at what are all the technologies that any organization can quickly get started. You look at the way the basic itself is the frames that we have, right? So we should also be able to team should be able to quickly go ahead and then leverage as minimum data points as possible, but at the same time go ahead and then be able to build the frames out of the information that you have. And you can see the ease with which here the engineer is able to go ahead and then develop and populate these frames, right? So you can see we're just using minimum sketch lines. With that, you are able to in the same user interface and environment, you're able to get rid of all those multiple iterations that are coming in. Any design changes keep getting updated, but at the same time you can share the same information back to the downstream deliverables at any point in time, right? So, and you can see the ease with which you are able to build. For example, if you have to have add any kind of gussets, if you need to make any changes here, right? If you need to add any caps there, if you need to quickly populate the frames depending on leveraging, you see here the user is basically going ahead and then populating all these frames on the fly. So you will be able to see the ease with which the user is able to populate the design. And then if you're able to see it towards the end, you can see the user is able to quickly build and then achieve from a frame standpoint whatever the design intent that is needed, right? So, and then you also see that at any point in time you have users communicating and then saying that the data comes in a very different file format. You'll be working with multiple collaborative teams or maybe different vendors as well, right? And they not necessarily they all will be on the same kind of design platform for you, right? But what you can do is NX provides you the flexibility to be on one platform, but yet at the same time be able to collaborate and then be able to bring in data from any other neutral file format or any other common CAD platforms. In this case, you can see the data coming in from a different platform, but irrespective of where the data has come from, you can see the ease with which the user is able to make changes to it, rather than going through an iterative process of sharing it back to a different sharing it back to the original vendor, requesting him to make changes, which will go into a couple of days and couple of hours. Also, you're just trying to get rid of all those iterative process here. You can see a classic example here. It's basically a rectangular cutout that is there on the sheet metal, but as and when you select and then try to make any modification to it without the feature tree or the history tree, you can see the tool is able to identify all the adjacent features, and then you can make changes to it at any point in time. You can move it, you can totally remove it, or if you want to move it, you can move it based on dimensions, based on constraints, and in a regular way that you would do on your traditional design modeling techniques, right? If the tool is also able to quickly understand, anybody would need the ability to understand whether it's a relief, whether it's a bend, whether it's a sheet metal this thing or not, right? So the goal is to look at the ability to be in a position to make any edits to it. You can see here it's a cylindrical cutout or a hole. You can say select all the holes that are there with a similar size, right, similar diameter. You can get rid of them on the fly, or maybe you can you have intelligent selection techniques in place. So these are all Siemens's synchronous technology that will help you to uh, you know be able to work seamlessly in a multi-CAD environment, right? So this is where there is absolutely no dependency for the manufacturer to be on multiple CAD platforms, irrespective of where the data is coming from. And by the way, if you also observe, you are able to look at reduced lead generation, reduced lead times in terms of regeneration that are happening. Any edits that you are making, it was automatically populating because it was not going through the feature tree. You could quickly make changes to the geometry on the fly, so you will not have to come across those failed features and all that. So basically, again, so I'm just reiterating the fact that all these minor productivity gains lead to a bigger gain when you're looking at the overall product development cycle, right? I spoke about sheet metal for a brief moment when I was talking about it in the last slide, but I just wanted to highlight a specific sheet metal environment that will give the users the ability to make the designs the way they would like, based on the need, based on the industry based workflow. And then you can also see the very vital important point here is that as and when we are trying to build, right, sometimes we may end up making a design that will probably create an overlapping feature when I'm creating a flat pattern, right? But what if me having the ability to see the flat pattern on the fly, and then get notified as and when as and when there is an overlapping feature that I'm creating, right? So you can see here that there is a parallel window that can help you to quickly try and understand, okay, this would be your ideal flat pattern, and then you will know how the design that you're populating, the design that we are working on, can get updated, and then on the fly we are able to make any changes the way we need, right? And basically you can also see the user using those standard library features, standard library components, thereby based on the industry based workflow, the user is going through the same set of processes, and then be able to make edits and then build the design the way it is intended, right? So basically, if you look at the modeling environment itself, you can look at the way in which the users are able to reuse the data irrespective of where it is coming from, be able to quickly achieve those design reviews and industry based workflows being followed, and then edit the models irrespective of where the native data format is, right? So still giving the user the 100% flexibility of working on the data inside the NX environment itself. And you can also see Romy, who's who switched to NX with increased, and once they switch to NX, you can also see they've been able to look at a 20% increase in data reuse, and then also be able to look at a 30% reduction in the number of seats that they were using. So basically improving more collaboration with concurrent design, and with a better efficiency as well. But then when you look at that was about most productive modeling environment. But then if you're also looking at mechanical design, it's not just mechanical design, right? It's also about electromechanical design, where we are saying you are looking at two separate disciplines working together, your design discipline as well as an electrical discipline, electronic team as well, right? So if you look at this data, so let me just, yeah, so if you look at this machine, right, so what all does it involve, right? So if you have to look at the first idea to the final machine, it involves a lot of disciplines. But if you have to just look at it in a little deeper sense, you can see a lot of these components are involved in it, in terms of cabinet design, in terms of placing the sensors, ensuring they're well in place, in terms of getting the valves, in terms of HMI, the way we are interacting with them, all these electronics going in with cabling, software also going in, right? So all of them. So we do have a lot of them working parallelly and together, right? So this, like I said, is not just mechanical alone, right? It includes a lot of mechanical and electrical software components. So that's where it's a mechatronic concept, right? So let's look at a traditional approach that any organization would have followed over the last couple of years, right, since inception. Usually from an engineering standpoint, we would gather requirements and concepts from the customer, And once it is approved from the customer, we go ahead and then start building the mechanical design, the detailed design. And then the next set of processes for electrical design and automation gets started. You wait for the physical asset to come in, and then the any organization would take the machine and then try to assemble it there in the customer place, commission it and the customer place, all this commissioning happens. And commissioning is where we would also see a lot of challenges also coming in, right? So what we are saying is, let us take a different approach. The approach of, once you have the concepts there, right, you try to reuse the same concepts, but parallelly you go ahead and then get started with your mechanical, electrical and automation designs. Since you're working on them parallelly, and then automation gets started by leveraging your mechanical design quite early in the cycle. So we are looking at trying to reduce the overall commissioning time, or overall time to which the asset is delivered to the customer and working and deployed. It's a good 30 to 50% reduction in the overall commissioning itself, right? So how do we do that, right? So if you look at this simple concept, it's basically a bottle filler, right? So you have couple of sensors which would identify the height of the bottle, and then the bottle filler will basically place itself at the mouth of the bottle, and then starts filling based on the volume, right? It's a simple one, right? So but how do we know if how is it expected to work? What does the customer want, right? So for that, one needs to go ahead and then quickly build uh, a simple concept, right, which needs to be approved by the customer. So but if you look at the overall machine, it includes a lot of other components, right? Be it mechanical, reusing a lot of other components that you had used in the past, because 80% of them can be reused, 70 to 80% can be reused, right? And only 20% can be where you can try and add more new components, or make minor tweaks to the data and all that, right? So you also have sensors and rest of all these things. So let's look at a quick example here. So let me turn on. So you can see a simple example where customer initially would have told us to, this is a bottle filler, this is one size, and then it should just work, right? So basically the sensor understands the height and then fills it. And then once you feel that, okay, the speed is low, you probably add it, make some changes. Imagine customer coming back and said, I want to use the same design, but yet I want to go ahead and then have multiple sizes of the bottles, right? So you need to quickly make some changes to it. So here now we have multiple dimensions to the flow, right? So you're able to quickly validate that, capture that, and then make edits to it. Once that is through, you take the same concept data, you don't have to rebuild it. Take the same concept data because it was already on mechanical. Take the same concept data, bring it onto your master design, and then incorporate it there. So basically you have the requirements captured, approved concept, and then once that is done, your mechanical design starts. With that, parallelly you can have your automation and electrical design get started, and then thereby you're looking at parallel processes, and then you're looking at shorter development cycle as well, right? So that's where your complete digital validation happens, right from your conceptualization on until here. That's where Mechatronics concept designer plays a very vital role, right? You can look at this simple example. So whatever that was being defined on the digital world, you can see the same way in which the asset is able to behave. So thereby you are looking at commissioning time reduced. So in this case here, we're looking at using Mechatronics concept designer, basically, which is an offering from NX. uh, Here the customer is able to see the real commissioning of the machine happening in 3 days, instead of which would have ideally taken about 3 weeks, right? So in even imagine, even if it is a 30% reduction, or even if it is a 20% reduction on your overall commissioning, that's a big number, right? So that will basically help you to look at this in a different way. Look at this and say that, okay, any changes that I need, you could have made all of them, and then that too without any risk of collisions happening on the real asset, right? So basically how your real asset will work, because you would have tested everything on the digital model itself. So again, reiterating the fact of having a comprehensive digital twin and the value that it brings in, right? So that's where Mechatronics concept designer comes in. So basically helping you to have ensure a seamless communication, no need for any kind of last minute surprises with the delays and commissioning, and you're able to track the way the customer concept that you're able to that was approved, and then be able to incorporate the same, right? So you can see here, with Tronrod, the world's fastest packaging machine, the slide I showed in the second slide or the third slide, if I'm not wrong, right? So they are able to achieve overall 50% reduction in production time, but at the same time, a better, a 25% reduction in the overall commissioning itself, right? And very importantly, no crashes, no physical crashes, right? So that's the whole goal when we are looking at electromechanical design. And then, like I said, once we build the product, we should also have the confidence, and we should also have the confidence that the integrity of the component is not compromised, right? It will work in the real world conditions the way we expect it to be, and without any crashes or challenges, right? So that's where we have also animation designer will quickly help you to validate the movement between the components. You're able to quickly understand and then capture all the measures. If you also want to capture the data in terms of your assembly, disassembly sequences, if you'd want to highlight, you can have them captured as well. And by the way, the user interface is same, and because it is well within the overall your modeling environment, we are looking at same the author of this data asset artifact can be the design owner itself, the design owner or the engineer itself. So, and you can also see the faster solving of the time in terms of the mechanism that we have provided, the faster solving, the way in which it is working. And this is scalable as well. So in terms of currently we may be doing it for one simple sub assembly. You can do it for multiple components of the assembly together and parallel. You can capture all these, you can capture all the metrics. In this case, we are capturing the measurement of distance between these two, here these 2 points, and then you can capture the same and then reuse it the way we would need later, right? And of course, regular analysis in terms of the vibration analysis. If you're looking at NVH data, if you would want to simulate the stress on the CAD model, right? Vibration simulation testing, nodal analysis, any of those common analysis that we would like to do for ensuring the product integrity is captured, we'll be able to achieve that well within the NX environment itself. And in a traditional way, of course, we all know that the way we have to go ahead and then do the manufacturing, it can also involve uh, your NC programming as well, right? So within the NX environment, you'll observe the capabilities and technology that will allow a user to go ahead and then quickly build the NC programming the way it is needed for the user. And you can see, I'll just quickly fast forward this a little. So just to give you an indication of how easily you'll be able to build the whole NC programming paths, all that, and then you can get started with in a very simple way, irrespective of what the product is. You'll be able to do and achieve this everything in an integrated product development platform, right? So not just are we talking about designing, and then not just are we talking about seamless multidisciplinary environment, we're also talking about manufacturing the same. We're talking about ensuring the integrity is captured. Once we're confident, we can go ahead and then on the manufacturing side as well, right? So that's what I just wanted to cover there. So if I have to quickly summarize, you can test the integrity of the product that we have built. All those common tests that we would probably need, NVH, stress analysis, all of them will be able to do that. And because people are able to access the data much faster, you are able to look at manufacturing and production and then delivery at a much faster pace as well. And because, again, like I said, it's a closed loop life cycle, you're able to capture the data and then build uh, better new variants as well, right? Here you can also see PM bearings, where they are able to look at better performance, also looked at in the way we are able to use automation designer, which is helping them to look at overall programming time getting reduced by about 80%, and without compromising on the structural integrity, they're able to have better simulation results as well. What is very important is the capture of the information, where we're looking at no error rates happening, right? So we are able to reduce the number of errors that are happening and then take care of it, right? So if I have to quickly summarize, we spoke about the product modeling environment. We are talking about seamlessly working in a multidisciplinary environment, that is electromechanical design, and then also check the integrity of the component and then also be able to manufacture. With all these in place, we should also be able to collaborate it, right? This is where it is very important to ensure that we are able to involve the key stakeholders here, right? So how do we do that? That's where a seamless collaborative design is important. And then sometimes it can be an engineer to order process, or it can be an assemble to order, or any of these things, right? So we would need to have a platform from a technology standpoint that will help an organization, a manufacturer, irrespective of what kind of process it is, right? So that's where, if you look at this example where we're talking about a configuration management, NX will allow the user to quickly go ahead and then quickly try out multiple variants, try out multiple configurations on the fly. And you can see in this example, we're trying multiple variants here, and then you can see the ease with which, in a simple user interface, you pick and choose what kind of functions you need. Do you need a bended to front door? Do you need a what kind of a door do you need? What is the overall variant do you need? In this case, it is V2000 that we are looking at, but what kind of feeder that you need? Do you need an in feeder or an out feeder, right? So what kind of an HMI positioning do you need? All of them you pick and choose, and then as and when you make this, you can see the user selection getting populated on the right side. But then, not just that, you also have a visual information of 3D thumbnail, that information that comes up. And then as and when I do that, you can also see I can quickly populate the 3D view, which is in the backend. It is already populated. I can have this saved, and the minute I save this configuration, it gets added into my library of saved configurations. So you can see I can go ahead and then quickly check and then say, show me all the loaded or saved variants. Let's say if this is something that the customer is looking at, right? So customer can pick and choose, or one of the teams can pick and choose, right? So once that is done, you say, okay, this looks good, let me show me the 3D variant. It is already up, so your bill of material, everything is populated accordingly, right? So basically this gives 100% flexibility for you to test out your variants and then pick and choose, right? So all within the single environment that we're talking about. And then when we say about involving stakeholders, we should also look at the ease with which you are able to share the data, and not necessarily all the time we are sharing a 3D CAD model to anybody outside the organization, right? But yet we are forced, or we are at a situation where we still have to share them enough information which is information rich, so that they're able to take the data and then be able to do the necessary downstream deliverables. Maybe if it's a manufacturing team, how do we go ahead and then share? The most commonly used is a 3D PDF format, right? So you can have a templatized format in which you can have a NX technical data package that will help manufacturers to go ahead and then take the original data and then be able to build in a templatized way. Once it is done, help you to populate and then dispatch it in 3D PDF format or JT plus PDF format and all that. And not just 3D models, because we are talking about a model based definition approach. You can also have all these common information that you can share information in terms of your dimensioning and annotation, any kind of supplemental geometry information that you would like to have, your sections that you would like to share, the if you'd also like to have a comparison of the PMIs is basically product manufacturing information that you would like to share, whatever that you have. Looking at this model here, right? The second one, the third image from the bottom, right? So bottom right, looking at this information, manufacturers are able to quickly see and understand, okay, if it is a 3D model, they are able to visualize it, and then you're able to share the information much better compared to a 2D drawing. And because the products are getting more and more complex, it would be vital to share the 3D format or in a 3D PDF, so that you're able to share information rich data, right? And you can also have, of course, your security markings and then searching and reporting as well, right? So that's why it is very important to have a communication in which you're able to share the data to the stakeholders. And in today's generation, we are also looking at people not able to travel, but yet we are in a position to make be we are forced to go ahead and then do quicker design reviews. So how do we do that? So NX, within the NX environment itself, one click of a button, users can go ahead and then do a virtual reality or virtual design review of the asset. You see this here. In this case, the user can just put on the VR headset and then see the same data, have access to the same digital model of the component of the product, and then he can take snapshots. He can do a lot of other things. You can, but basically from a use case standpoint, you can use it for your stage gate design reviews, operator know-how or service training if you'd like to have. If you'd also want to share this data to your customers, you and the customer can be together. Let's say you are in Bangalore and your customer is in Chennai or California. Both of you can see the same data together using the VR device in real time. Okay, because it's already built in NX, you can see the data in terms of the metadata properties. You can capture all of them. You can hide couple of components if you want. And from a design review standpoint, commonly you may also want to capture, uh, what do I say? In this case, I would want to capture the height between the bottle top and the filler, right? What would be the height? Can I work on that? Maybe should I reduce the height or should I increase the height distance between the two? I can do that real time, right? So this is something that the customer can try. This is something that you, if you have teams placed across different geographies, you can do that. Any of those collaborative reviews, you can use it, and all everything in the NX environment itself. And imagine if you have if you are wearing the VR headset and the customer is there on a different location, he's on a VR headset, both of you can work together on this parallelly together in the real time, okay, on the same asset. You can capture all this information as snapshots and then be able to go ahead and then share that. So basically, people don't have to travel from multiple locations if needed. If you want to use it, use technologies like this to go ahead and then achieve your virtual design reviews as part of the workflow as well, right? And then imagine a situation where you have imagine a situation where you may need to have ad hoc collaboration that needs to be done, right? So at that point in time, you still need to work with your vendor to share the data, and then it goes into multiple variants, iterations, and then you are forced to share the CAD data, which is in a different kind of a file format, and all those things, right? It goes into multiple circles, right? And it becomes a little complicated process. That's where we have accelerator share. Let me give you a quick example here, right? So in this case, there is a impeller that is there where you can quickly need to go ahead and then look at it, and then the customer says, the OEM basically tells the supplier saying that there is some issue here, is there a possibility to improve it, right? So basically, well, within the user interface itself, the user can go ahead and then open accelerator share, which is our platform, to go ahead and then create a new project on the fly. As and when you do that, you can add stakeholders for that particular project. In this case, the OEM guy will go ahead and then add his external supplier to this project, and then supplier will have access to the 3D data then and there. So the supplier quickly sees this, and then here Sally, she quickly sees it and then creates an internal project. She'll go ahead and then share this to her internal team. Okay, in this case, the design engineer looks at this data because they would have got an update, right? He'll go ahead and then, let's say, he'll increase the number of fins here, right? So once he does that, there is a change in design, right? So once, because of the change in design, you need to check the structural integrity of it, right? You need to check the flow, all of them, right? So he quickly makes an update, but then he will go ahead and then request his simulation guy to do a quick check of the product, right? So to give him a confirmation that it's well within the working limits, right? So the engineer quickly checks the flow because it's well within the accelerator share. Everybody's working on the right variant. You will quickly go ahead and then select, and then you can use SimCenter's analysis tools to go ahead and then run the analysis, and then get the data. Once you get the data, right here, you can run the analysis and then share the results back to the design engineer there, and then he gets a confidence that, okay, this is good. He'll do a final test run on on the structural integrity of the component. Once he's confident, right, once he's confident that it meets all the needs, right, he'll basically load all the information that he has from a loading standpoint. Once that is done, he's confident it's all good. He'll know all the results are well within the acceptable limits, right? He'll send it back to Sally, and then Sally will get to know that and then Sally will get to know that uh, uh, this is good enough, and then you send it back to the OEM. So basically, since OEM is looking at this data, and then they're able to just download it and then incorporate it back. So this is, if you're looking at an ad hoc collaboration, you can go ahead and then look at Accelerator share, which is very vital. So for you from a collaboration standpoint. So again, I'm talking about how it is useful. So if I have to quickly summarize Collaborator share, it's secure cloud storage. You can also have desktop file syncing as well, and this is per project. You can have permission based project sharing, task management in place. You can also use augmented reality for let's say if somebody wants to see the same data, they can use it on their tab and then place it on the floor or the table, and then quickly check that you have your messaging and notification can be accessed on any device as well. And multi-user override production is also there, right? So I just wanted to highlight on these points here in terms of configuration, change management, high fidelity viewing across the enterprise and all that. So as a customer success, you can also see in terms of how Bosch is able to look at, with the adoption of a complete digital twin, uh, they're looking at reduction in the costs, and more importantly, because you are sharing accurate product information, things are only getting more and more productive, right? We spoke about generative engineering at the beginning of the slide itself, right? So I'll go through this quickly in the interest of time. You can see this slide basically is an example of, if you look at uh, these images here at the top, basically all the three at the top are all man-made, right? So they're all man-made objects, right? But if you actually properly look at it from the nature, so be it the mountains or the rivers and all that, none of them are straight lines, right? None of them are straight lines, but yet at the same time they all have withstood the forces of nature, right? Be it the mountains, the rivers and all that, right? So that's where generative engineering is design inspired by nature, right? So in terms of what happens is, you can look at the design requirements in terms of loads, materials, boundary conditions, everything, and then define the needs of it, and then let the generative engineering tool to leverage the power of your computer uh, to go ahead and then run an analysis, arrive at a design which is inspired by nature, to help you to come or arrive at a design which is probably less light in weight, and then yet at the same time without compromising on the integrity of the component. So this is very important. So while we are looking at lightweighting the design as much as possible, but we should also not come out with a design that is that will give off very quickly, right? So that is where it is important. So you look at this example where we're looking at uh, this design, and you can look at this design where we pick up this component and then say, okay, I need to make some changes to it, right? So uh, uh, because of convergent modeling from Siemens, right? So I will be able to go ahead, and you can see this is a generative design based on the fitment areas that are there. These are all keyboard zones that we have defined, and then let the software run an analysis and then come out with a design. But then the minute you look at it, there are few thin walled zones are not allowed, and then there are few thin features that are there. It will be difficult. But you can see, even though this is created by generative design and they're all facet models, Siemens's convergent modeling technology allows the user to work on all three types of data models, be it your surface, be it your solids, be it your facets, together in the single data itself, single model itself. So in this case, even though if it is facet data, you can see the ease with which the user is able to select this region of interest and then say, okay, this is too thin, I need to go ahead and then probably thicken it a little bit, right? Maybe make it a little more stronger, right? So while the generative design would have given you some shape, if you want to make some minor edits to it, the user will still have the ability to do that, right? In this case, again, if you want to go ahead and then add a fillet, right, a secondary feature to it, you can go ahead and then select the points on this edge and then say generate a fillet for me, right? So the tool will automatically help you do that. So basically there's absolutely no need to do any kind of reverse engineering, and you have n number of extreme high amount of flexibility to do design, right? So that's what we are looking at. And generative design basically helps you to try out hundreds and thousands of alternatives for your design, arrive at better design that will help you to make things as light as possible, and all by just harnessing the power of your computer, right? This is one example where we're talking about HP. And I'll drive this a little faster. You can see this flow. So based on the CFD, right? So you quickly run a flow analysis. Based on the flow analysis, you realize that a lot of you would have probably understand where the maximum loads and constraints and results are coming. And then based on that, right, the user can quickly go ahead and see wherever there are less amount of flow happening, right? You can try and see if you can optimize the design there. Where the maximum amount is there, you can try and see what can be done, right? So based on that, the user is able to go ahead and then optimize the overall design, right? And then you can see with the optimized design, right? So it includes it is a much better improvised design. You can see the one on the left is the original one, and the one on the right is the optimized design, right? So how are they different? You can see the results with your own eyes, right? So how do they help in terms of, you can see the way in which these design changes have affected, and then giving you with the original one compared to the optimized one, you're looking at a better mass flow itself, right? So coming to the last one, right? So I'll be a little quick. We are also talking about additive manufacturing, right? Additive manufacturing in terms of adding lattice structures to also be able to go ahead and then leverage it for your 3D printing, right? So the idea is to be able to leverage your generative design, be able to achieve your topology, and then lightweight it. With with respect to this, you can also go ahead and then add lattice structures and all that. That's where you can have to have a seamless integrated platform that will help you to achieve your generative design, right? So I'll go through this a little quickly. From an industrial additive manufacturing standpoint, the idea is to look at how do we achieve lighter components using the way and manufacturing methods of additive manufacturing, using lattice structures in a seamless way, single user interface that will help you with a dashboard to quickly be able to arrive and then use lattice structures within the component, make them as light as possible, but without, of course, the compromising um, on the integrity of the part, right? So here you can see we're talking about how they're talking about complexity getting reduced, and low error rate, because you're working in a seamless environment and without any errors in one single process chain, right? And so if I have to quickly summarize, we're talking about, we spoke about the way in which you can use the most productive modeling environment to boost the productivity of a team. And also, since you'll have multiple disciplines involved, is where you will have electromechanical design, a seamless platform to help you in that is very important. Once you have the product, you should also be able to test its integrity and then be also able to manufacture the same. We're also talking about, once you have all these things done, you should also be able to collaborate with multiple stakeholders. We spoke about how do you share the data, do your configuration design, how do you use accelerator share and all that, use the power of your computer for your generative design, arrive at shapes designs inspired by nature, and then leverage additive manufacturing as well, right? So this is what each of these technologies that we spoke about. And then a big example here is where next Rom we're talking about is looking at uh, good 50% half reduction in time, right? So for your new development, so that's a big number, correct? So if you also look at it, in the beginning of the slides, I spoke about the amount of investment Siemens makes for NX, right? So you can see here we've won the award in AI Connects, that is for your artificial intelligence. Basically, NX as a software is able to quickly predict what would be the next command that the user would need, basically based on the artificial intelligence, based on the user workflow that is there, right? So all of them that are there, right? So from an adoption standpoint, so this is very vital. I'll take next three more minutes maximum, 3 or 4 minutes, and then we should be open for questions. I'm sorry if there's a delay, so I'll make it very quick, right? So from an adoption standpoint, for any SMBs or any mid-sized companies or any organization, any manufacturer, is how do we look at these solutions and then be able to leverage them in your own product development, right? So you can look at, it can be used as perpetual licenses, subscription modeling, and then subscription license as well. It can be deployed on the site, or it can be cloud based as well, or also has an hybrid approach as well, right? So, but let us take a good example here. Imagine you would have already had you're all manufacturers, and then you all would already be having some kind of modeling software in one way or the other, right? And I'm sure you all have come across this discussion with your vendor where he says that, sir, if you need to work on high type of modeling technologies, you may need to buy an add-on license, right? And then not every time you would while that add-on license is very important for you, but not every time you would use it. You may not use it every day. You may use it once a week, or maximum twice or thrice in a quarter, right? But you still are required to pay for it, maybe for an entire year, right? Even if it's a subscription license, which does not look feasibly which does not look quite good, right? So let's consider the same scenario here with Siemens when you're talking to us. And then, let's say you as an organization, start with a couple of seats of Mac 1, which is our basic entry level bundle. And then you would have about 100 tokens. Okay. Let's say at 9:30 in the morning, one of the users wants to do human modeling. He may wants to do understand what is the height and reach analysis and all that, right? Human modeling. So based on respective module, that module will have a certain number of tokens. So when you launch that particular module, user one, he'll consume about 26 tokens. So 100 minus 26, you're looking at 74 tokens, right? And then the other module, maybe engineer two wants to do aesthetic design, maybe an ergonomic design, maybe he wants to do, styling, right? So that will, again, based on the module, it will consume its own respective tokens of, say, 35 tokens. 74 minus 35, you're left with 39, right? But engineer one is done doing his add-on modeling and human modeling. He'll shut the license down. Once he does that, this 26 will go back into the pool. So meaning these tokens are not consumptive tokens. So you can replenish them as and when you release these tokens, which are in use, right? Somebody wants to do quickly base routing, right? You can get 25 tokens, right? So that is the goal. And then your question is, okay, this looks good. What is it something that I can look at, right? So what all kind of modules? So NX has about 60 odd, add-on modules, and then you can look at any of these add-on modules. And then most of these add-on modules is something, all are the add-on modules that you can use as part of your token licensing, except the last column and then this, which is more than 100. If you're starting with 100 tokens, you can use all these add-on modules, be it Mechatronics concept designer, all your routing player, and then industrial design and styling. If you're working on tooling and fixture, all the common translators. If you're looking on mechanical design, human modeling, advanced sheet metal, weld assistant, visual reporting, animation designer, we spoke about it, structure designer, we spoke about it, PMI, model-based definition, algorithmic modeling, all of them, right? So that is, that will give you a flexibility of using close to access to about 50 plus add-on modules uh, by just looking at 100 tokens. That will be a good way to start, and at any point in time you feel the usage is more, the customer can quickly go ahead and then add 50 tokens or 100 tokens in the multiples of that. So with that, I just wanted to come towards the end of the presentation. My apologies if I took a little more time, but I think I'm open for questions here.
Thank you, Avinash. Excellent, excellent. Thank you for
Thanks,
taking us
Vishal.
through in such a detailed way. Firstly, I would like to understand, there is one question on CAD software. Is there any easy CAD software for students? And is there any student version of NX as well? If you can highlight on that.
Yeah, so if you log into Siemens website, there is a student version available for trial that can be accessed on the cloud. So they can start there. So there are trial licenses of NX available there, and it is called as NX. I think there was one question on which CAD software is used in Siemens. So
Yeah.
Siemens is basically the CAD software developer. So the NX is from Siemens.
There's one question. Can you share any success story of multi-site installation and highlight on project security and concurrent design across multiple locations?
Could you elaborate, whoever the question was from, could you elaborate more on multi-site deployment? are you talking about how the data gets shared? If that is the case, our biggest install, I mean, most of our customers are all on our CAD as well as PLM platform, which is on Teamcenter. And then, we have our customers are accessing this data seamlessly across the globe, across teams, across verticals, without any challenges. And security wise also, all of them are taken care. And i- it's a testimony in itself where you have live customer data being shared, and a lot of customers on using Siemens logo. So should not be a challenge there. And there are multiple ways in which you can share the data. If the question is all about security, the data can be on two things. It can be an on-premise installation, or it can be a cloud installation. If it's a cloud installation, you would have probably heard a lot of certifications needs to be done even before you launch, even before any customer would be looking at billing at cloud instances. So a lot of those certifications, approvals, everything are there in place. And yeah, both on-premise, cloud, both of them are there. Should not be a challenge, and data can be seamlessly accessed. Yes, that's true.
I don't know. I would also like to understand if there are people from multiple locations working on a similar project. So concurrent design across multiple locations. How easy to use NX can be?
Yeah, of course. So, like I said, there are technologies that are available that will help you to work in a concurrent way. So the users will have access to, uh, let's say a classic example of the laptop, right, that is in front of us, right? So somebody would be working on the display, somebody would be working on the keyboard, somebody is responsible for a couple of electrical components inside, right? So you would have multiple team members working on that, right? So the ideal scenario is to go ahead and then have the overall top design in place. Once that is done, you would have probably defined what are the subsystems that are coming in, and you would have to have an ideal top-down design approach, and then have relevant references being shared, and then everybody can take it forward from there. And then at any point in time these changes are happening, those references get updated, and then at any point in time most of the users are and always working on the latest information of the data.
Okay. There's a question on the cost of license as well. So do you want to elaborate anything on that?
That is something that I would request them to reach out to me on a mail. My email ID is something, if I can share. I don't have, so I'll drop in my email ID here, or if they can reach out to us after this, should be fine.
Does Siemens provide service for the software? If I discuss the requirement, can Siemens provide a complete package end to end from design to production of the machine?
Yeah. So when you say service, if you're looking at buying the software and then helping the customer to go ahead and then adopt in a successful way with training, and if there's any automation needed, it should not be a challenge. We'll be able to do that. And then I can have that discussion with them on maybe it needs to be a little elaborate one-to-one discussion, but that's something that I can do.
So, Avinash, just because the question was here, I would like to understand, can this be customized depending on what kind of requirement the company has? Or is it like one software fit to all?
Yeah. So, like I said, so there are, depending on the organization. So I spoke about a lot of add-on modules, right? I showed them, and then there are base modules that are available. So depending on their use case and then what part of the product development that they are in, we'll have to look at. That is the reason I said we would need to look at having a one-to-one discussion. Based on that, we'll be able to arrive at what would be those respective technologies that can help them, that they should probably get started on phase one, and then maybe look at phase two or phase three on from an advanced standpoint. But yeah, they can pick and choose what are the ones that are needed, and we also would suggest where they should get started. For us, if you ask me, I would not suggest to go big all in. I would suggest to start small, adopt successfully, right? Once you have the confidence and the team and the familiarity in place, that is where you can always scale up. So NX is a very scalable tool, and so that's never a challenge. So start small, uh, get adopted, and that's the reason we spoke about multiple levels in terms of you can access these add-on modules, and I think we are the only vendor doing it right now. So from a CAD standpoint, yeah.
This is another question on,
Please.
firstly, people would like to understand how long does it take? What's the total duration to learn NX completely?
That's a good question. And we are doing a lot of things on NX itself, and especially the CAD modeling environment. So every release. Oh, by the way, so if the team is not aware, I think I've not highlighted. So NX is a continuous release software, meaning like I said, there is a new release of NX every few months coming in, maybe every 6 months or 8 months or so. So you would probably see more and more new releases of the software coming in, which also means that it's, of course, again, it's a testimony in itself, which also means that a lot of improvement investment in the R&D is also going there to improve the user interface, adoption cycle, reduction, everything in this, in that as well. So if you ask me, if you are already familiar with, I think most of them by now, CAD has been there for a long
Yes.
time, and most of them are already familiar with one kind of a software or the other. If you have that kind of a knowledge, it's not going to take too many days. It's going to be very, very minimal time. And whoever has looked at NX definitely has really, really liked it.
So do you also provide the training necessary if the company is adapting NX?
Yes, we do that. We do provide that, and it can be tailor made also depending on what they need, because there are organizations who would like to have it done for their industry based workflow. They may not like to have it in generic, so we can try that. We can have, again, it can be a one-to-one discussion to try and understand where they stand, where they would like to start, and they can pick and choose. We can do that.
There's another question. How
Please.
to use NX with TIA portal? Do
TIA portal.
we have to use any add-on, or is it available in NX?
So basically, you'll have to look at, there are a couple of modules with which you'll have to look at it, maybe using the NX Automation Designer that I spoke about. Um, if needed, I can get my team to do a technical session to them. But yeah, that is something that you will use basically once you have the Automation Designer, all the relevant work that you would have done on MCD, that is Mechatronics Concept Designer. You'll probably use that to share the data onto your physical asset. So I can have the team to communicate to you on the right workflow also. If at all you are looking at that, you can reach out to me on a one-to-one.
The next question is,
Please.
how are the placements on NX? What are the core companies that are working on NX?
Very good question. So uh, if you look at all the big OEMs that are there, a lot of these OEMs are already on NX in one way or the other. And then if you're if you're following, I would have also posted, and Siemens is basically posting a lot of updates that are coming on NX, and a lot of companies who are on traditionally on different CAD platforms, all of them have also moved on to NX. And the reason why it will only get better is also because the reason with which the ease with which we are able to manage all kinds of data. If you all have heard, I think this question is coming from a student. You must be also be aware of the kind of data format that is there, which is parasolid, right? So usually this parasolid kernel is also owned by Siemens, right? So all most commonly used CAD formats are all parasolid, and it is already owned by Siemens, and we are able to seamlessly work on any kind of CAD formats. And most of the organizations are, you would have seen a lot of new wins that Siemens has got. uh, yeah, I mean, the potential is quite high for anybody on NX.
Uh, there is there is one more.
Mm-hmm.
Which branch of engineering students can take this software? It's again from a student. Probably I can just take one more question which has come.
Please.
Can immersive design help us migrate from traditional project lifecycle management? And is there a specific training for the employees?
Yeah. So again, see, immersive design is like a jargon, right? It's if you would have heard, a lot of people also use this word called as digital twin. Somebody, it depends on what they mean, right? So it can be just the CAD model, it can be a digital process, it can be just to get the data from the sensors, it can be anything, right? So again, the idea is to look at and understand, if of course, when we say immersive design, it's mostly digital, but at the same time giving you, experience in terms of a 1:1 human scale kind of an experience, where we're looking at, VR as a technology. And the other day I was talking to another customer, and the adoption also is in terms of, you would have all heard about the metaverse coming in, right? So everybody's looking at, how do you look at all these digital technologies, try and leverage them, and all that. So yeah, immersive is something that's certainly help you, but definitely it's not a replacement of your existing overall methodology, but it will add value to where you have. So we'll have to, if you ask me, I would probably put it this way: I would like to look at and assess what's your current process, and then probably suggest where you should look at, because for me the adoption is very important. So that's where I'll say, this is your current, hey, this is what we see in your current process, and these are the regions where you can probably look at, and then, improvising your process.
There's another question. In terms of designing, how can we show the selling point of NX when compared to Creo or SolidWorks?
Okay, so I'd probably I'll probably put it this way. So I will not talk about the other tools that you spoke about, but I would like to certainly highlight a couple of pointers like I already done in terms of the investments that we're making, in terms of the ease of use with which you can make. And then, in terms of the large assembly management capabilities that you would see, the other tools, you'll find it difficult to, you know manage those large assemblies that are there. And then, also I spoke about, the industry based approach that we're taking, right? It is not just tools or models or licenses that we're talking about. We're talking about an industry based approach. Let's say, for example, a classic example is Mechatronics concept designer, right? Basically helping you to build the concepts and then use the MCD tool, NX automation, to actually do your commissioning itself. So how often have you heard the other vendors talk about commissioning on the CAD software, right? So we're talking about an industry based approach. So that is our path, and that is where our differentiator comes in. And we're certainly no less in terms of, if you ask me, will be much better in terms of managing any kind of an industry based workflow that you're looking at, and any use cases that are there. I'm more than happy to take your questions in detail also if needed.
It's not a part of the question, but I just want to understand. We When we started, we talked about how it is helping the small and mid-sized companies. So I just want to understand, how can a company which is using a traditional method of project design use this, and what kind of ROI can they expect from using NX in their daily work?
Yeah, so I spoke about value based licensing, right? So let's say if the customer is already there on any XYZ platform, right? It can be on any other CAD platform, or if they're already on NX, anything is fine, right? So the couple of pointers here is, once they feel that, okay, maybe let's say a classic example of Mechatronics concept designer, or automation designer, anything that they would like to use. So a classic example is when you're trying to do that, more often than not, when the challenge is in any CAD platform also, you are asked to buy higher add-on licenses. And like I reiterate the same point, you don't use add-on licenses on a daily basis. Nobody would use that. They will use it, a couple of times a week if it is a high usage, or they may use it couple of times in a quarter or 2-3 months, right? So, but you would not use it on a daily basis like I would use a base license, correct?
Yeah.
But these licenses these add-on capabilities bring a very vital differentiator to your product development, which is acceptable, which is absolutely right. So what we're doing with NX is giving all those vital capabilities to customer in a flexible pool, where they can access anything they want. Let's say from Monday to Saturday, if you're working Monday to Friday, you have about 5 add-on technologies that you would like to use. One day you want to use additive manufacturing. Day 2 you need to use Mechatronics concept designer. Day 3 you may want to use schematics or modeling, routing. Day 4 you want to use advanced modeling. advanced assembly, you can use all of them. Why pay for all of them when you're not using every day? Have the flexibility to use it when you want, right? So that is what we are looking at. And imagine, even if you're an SMB, right, even if you're a mid-sized company, but imagine having access to 50 of the best in class technologies in the CAD modeling world. That is what I'm talking about. And I spoke about Mechatronics Concept Designer, right? It was right at the top in the add-on pools. It is available as part of the tokens. So you can use any of those things: staged models, die engineering, electrode design, right? So depending on, let's say today you may not have, the SMB may not have a use case for tooling and fixture, but tomorrow, let's say they are getting a new project, right, and then they want to test it out. So ideally they go back to the software vendor and then say, I'm getting this project, I need to test it out, can you give me add-on license, can you give me trial license, I want to test it and all that. But imagine you're already being on NX and value-based licensing is there. You can use these licenses, add-on capabilities right from day one, right? So that's the whole idea.
So Avinash, these are the questions that we have. I would request you to summarize if you have any additional pointers to share with the folks.
Well, yeah. First of all, thank you everyone for your time, and really appreciate the questions. And I hope I've been able to address your questions in a manner in which you are able to understand. If not, always feel free to fall back onto me with any kind of questions. Reach out to me with any of these pointers and queries. I'll be more than happy to do that. So just in order to summarize, what we spoke about today is in terms of the key trends that are there, in terms of all those uh, challenges that will come as part of these trends, and then how Siemens is helping customers address this in improvising their product development, improvising on the productivity, working on a seamless electromechanical design environment, working in a way in which you are able to manage, check the integrity of the component, manufacturing of that taken care, working in design, generative design environment, additive manufacturing, right? Also be able to collaborate the data, share it with everybody, right? We spoke about all the best in class technologies, and then how any SMBs is able to adopt this using value-based licensing, right? So the token licensing, right? So having access to about 50 plus add-on modules, 50 plus, I just repeat that, 50 plus add-on modules to go ahead and then, uh, access them right from day one in production, right? And then, giving you full flexibility of, high-end technologies at any point in time. So I just wanted to use this as my summary, and then, yeah, that is it. Thank you, Vrushali.
Thank you so much, Avinash. Just to tell all our audience, we have put the email address of Avinash in the chat box. If anyone wants to reach out to him directly, please do so. He'll be happy to answer any questions that you may have. Also, we do have upcoming webinars, and stay tuned. Our team will reach out to you shortly on the details and the topics of the webinars coming up. With this, I thank Avinash for his valuable time and valuable inputs, and stay tuned to this for more coming up.
Thank you, Vrushali. Thank you, everyone. You all have a good day.
Thank you. Have a good day.